Carl from Studio Incar. Little bit of a bonus episode today. Today I'm going to teach you a few steps on how you can sort out your system or diagnose it if you've got no sound, either full no sound or no sound from certain speakers. We're going to have a look at the signal path and we're going to use a process of elimination to figure out where our potential issue may be, if we can find our broken product or if we can find that thing we've done wrong. Let's go. Back in the game. So I'm going to run you through one real world scenario, which I'll explain in a second, and then possibly two sort of dummy scenarios where I'll throw something in the air and I'll see what we can do to resolve it. And hopefully the processes will teach you a few things about how you should diagnose or how you should look for certain issues. We all have them, you know. What we don't do as a business is fix other people's issues and other installers' issues and stuff. It's just not what our business is about. But of course we have to take care of all of our clients with our lifetime warranty on what we do. You know, so quite often we can find ourselves diagnosing scenarios, dealing with them, getting them sorted and getting them back on their way. The van currently has an issue, and I've held off. It's been painful driving it with no sound, but I've held off. So I feel your pain, anyone that has any snags. I've held off repairing it because I thought it's good content, this, because it will teach people things, or at least unlock certain levels of processes that you need to do. I've been a pro for years, and we all have our specialist topics within here. Although we can all do the complete job, we all kind of excel at different things. Integration and diagnosis is probably my standout. I love fixing things. I love making things work where they shouldn't. I love getting a good signal out of a bad sounding car, things like that. So let me thrust upon you some of my knowledge. All right, let's go to the board. I'm going to draw a diagram before we start fixing the T4, which we will do. It doesn't stand a chance. All right, it's future me here. It doesn't escape me that you can't see a thing on this whiteboard. All right, I swear it looked fine on the camera. As you watch it, as I get closer and further away from the camera, the white balance adjusts and you can actually see the picture, but you just have to try hard. Sorry about that. Right, we're at the whiteboard, so you know it's getting serious. This is coming out of me raw. This isn't scripted, so forgive me any mistakes on the board, but we're going to draw a simple system, and then I'll draw a couple of things that are relevant to what's going on in the van at the moment. Head unit. So this is the first scenario, okay? We've got a head unit, we've got an amplifier, alright? And we've got active mid-bass, and then we've got passive mid-range and tweeters, alright? I'm doing this because there's different scenarios for active speakers and passive speakers, alright? There's another link in the chain, effectively. So, we're driving along and our right mid-range goes down, so this one. These are mid-range, tweet, mid-bass, okay? Amp. Driving along and our right mid-range goes down, okay? Now, because we know there's a passive crossover in the line, but we need to know the signal path first, all right? So we're getting sound and systems, when you revert them back to their sort of rawest form, a very simple thing. It's kind of just a one-way street, all right? Source creates the sound, whether that be low voltage, high voltage, depending on what you're doing with your amp, but that sound, if it were, or that voltage is coming from the radio to your amplifier or directly to your speakers, okay? So it goes in just one direction. So we know that we can pretty much remove stages going further back to eliminate parts of the process to see where that issue might lie. So if our right mid-range has gone down, for me, I know everyone will have their own ways of doing these things. The first thing I would probably do is actually whip this driver out. I'd whip this driver out and I would put, just another driver in its place. Just not fit it, just even if it's a mid-bass or whatever, something that can deal with the range of frequencies that's playing. So you probably wouldn't want to put tweeter on there, but another relevant driver, in terms of spec. I'd put that on there and I would see if it had sound. If it did have sound, then we've got a blown driver, we've fixed the problem, or we found the problem. Yeah, we need to order another set of speakers. Some mid-ranges can't be bought individually, so you know, we'd end up with one spare. But if you're that way of, if you're that type of listener and you're listening to it loud and you've blown a mid-range, then you might want another one in stock anyway. If you take that out and you swap it with another mid-range and it still doesn't make sound, jump each step back each time, eliminating each step. Now, we know, because this crossover is common with these two speakers, we know that the input to that crossover is okay, all right? In one way, we know that its voltage is okay. We know that it's getting signal on that speaker cable because we're still getting sound from this tweeter, right? What we don't know is if there is a high pass filter in the amplifier that's been switched over, all right? So we need to then look at the frequency range. So if we've got a high pass filter on the output of this channel and it's gone, say, 5k, 6k up because someone's flicked it by accident. You'll see where my amp is in here in a minute, and if it didn't have a case on it, there's a high possibility someone could flick something on the amplifier. So you need to prove the signal, okay? So prove signal. How do we do that? We either look at the switch on there physically, make sure that it is in a bandwidth range that is, say, high pass to 300 hertz, or wherever your mid-range might be happy, wherever you would have set it up. That then opens up the whole bandwidth for that to play. And if you did that, if you flick that switch and this starts playing again, you would then have your mid-range and everything would be working again. So that's your, you know, your second fix done. You know, this scenario isn't likely, but if it had individual high passes for left and right, which they don't often do, I wish they did, but they don't often do. If you check that switch and that switch is fine, that means that this is okay, right? The closest link to the damaged speaker being okay moves the problem on, all right? So if this has got the full bandwidth of frequency on this cable going into this passive crossover, you know that that should be playing. If that's connected to there, that should be playing. So then you have to check your crossover. Is there any settings in your crossovers, like your passive crossovers effectively, that could have switches or bridges that have been removed or something like that? Check that, see if that's okay. If that's all right, then you've got a problem on the speaker cable itself, all right? Because again, if you check that off and that's got everything it needs and it's getting an input signal and all of its bridges are in the right place, then this cable here has to be the issue. If it doesn't play with another speaker once you change the speaker, which is the first step. So you need to prove these steps, kind of going backwards. So to the point where you would jump from the speaker to the point where that signal becomes individual, all right? Because we know the tweeter's playing, we know that we're getting signal from the head unit, we know that we're getting signal from the amp, all right? But we know that these are on different bandwidths from the passive crossover, so we need to prove this switch, this high pass switch. We need to make sure that cable's got the correct signal. We need to make sure that passive crossover is outputting or allowing through the correct bandwidth for the mid-range. And once we've done that, we know that our problem is going to be here, all right? So in this scenario, if you'd replace this speaker first and it didn't play anything, and we've checked all of these things and we know we've got signal coming all the way through to here, then we know we've got a problem on the speaker cable. At that point, what I would do is I would fit a speaker cable from this passive crossover to this speaker directly. I wouldn't install it in the car, I would just go from the passive crossover wherever it's fitted, and I would take it round and I would just plug it into another speaker, one in my hand, and it will start playing. You can pretty much guarantee that because there's no other points in this chain where it could be broken. So that's kind of working out 4 different scenarios on one individual speaker that could potentially be the issue. You're not going to have an issue here. So this is what I see quite often, is people chasing their tails when it comes to diagnosis. And it's actually, once you understand the signal path and each stage in which the frequency bandwidth can change, all right, you know where you need to start from. We know this is playing. we know this is common with this driver. So we know that that signal is getting to there, this signal is getting out of there. We know that there's signal on that, but there's no signal on this, all right? So that would lead me to immediately believe I've got an issue with the passive crossover. We've checked the passive crossover and the passive crossover is okay, all right? So it's gonna be the speaker cable, and in which case we run a fly lead and we check it, and that's it. That's that problem solved, all right? This speaker would then start playing, because the problem will be that's either snagged in a door, it, you know, split in like the door grommet, or it's just come off the speaker. We would know that because we took the speaker out originally. If check this, you know, obviously you would check that, you pull it out, cable's not connected, you plug it back in, and this whole problem's solved and gone away, and we've just wasted 10 minutes explaining it. But yeah, hopefully within that's about as simple as it gets. You can see that there is quite a simple process to keep your eye on the signal path. Check each time it can change, because there's so many points in where it can't change. There's no point in you chasing that. There's no point in you chasing any errors in that area, because what can happen there can't possibly affect that dedicated mid-range on its own. But what it can do is the next scenario. So I'm going to rub these little bits out. I'm going to keep this system the same, and I'm going to explain a no sound scenario. Right, so a no sound scenario, okay? So no sound. Most common of all issues. I've had to bring the battery into this, because of course if we have a duff mid-range, i.e. in our previous scenario, we aren't going to have a dead battery, all right? So I've brought the battery into this, because this now affects grounding, it affects power, it affects fusing. So what do we need to do? We're driving along, again, we whacked it up a little bit, or we might not have. We might have just been talking on the phone, I don't know, and our stereo goes down, all right? Couple of different ways our stereo can go down. Our radio stays on and our amp turns off, all right? Or our amp stays on and our radio turns off. If our radio turns off, our amp turns off, because it's wired correctly, because there is a remote cable running between these two, all right? We should always have a remote governed by the radio to the amplifier rather than an ignition feed, okay? Simply because we don't want our amp on if our head unit isn't on. It's kind of pointless. Other scenarios with that would be maybe if you're streaming, if you have a van and you go to the beach and you want to stream to your amplifier, you might have your amp on a switch or on an ignition switch, or you might run it from a secondary battery like I do. So if two possible scenarios, amp off, don't know if you can still see that, or radio off, okay? Sort that out. My handwriting's dreadful. If our amp's off, okay, so like I say, we're driving along, no sound, okay? Radio's still on, but our amp has turned off, okay? Two things we need to do, okay? First thing we would do is we'd have a visual look at the fuse. We'd just check the fuse just to see if it's okay. If we can't see if it's okay, you can never eyeball a fuse. You should always meter a fuse, all right? Check voltage on the other side of the fuse or at the amplifier, okay? We've got voltage there, okay? So we've got voltage here, right? So it can't be that. Our fuse can't be blown, all right? You can, if you're questioning your fuse still, you can take it out and test continuity across the fuse if you can't visually see that it's blown. 9 times out of 10 you can visually see that it's blown, but you should never just trust your eye unless it's blown wide open, all right? You should always check it. So we know that we've got power there, so that's just this scenario. There are other scenarios where we won't have power there and we would change the fuse and then badoom, we're back again, and we've been a little bit too lively with the volume. Or we might have a speaker that's breaking down, which is causing the amp's fuse to go, and therefore it goes on and on. But in this scenario, we've got good power at our power connection, right? Check our grounds anyway. It's always worthwhile checking our grounds, but in the majority of problems, if your amp's just gone down out of the blue, it isn't going to be because your earth cable's just come loose, all right? Sometimes it will, but you will have noise on your system, like noise for days if that happens, as it tries to offload grounding through everything else in the amplifier. So we know we're good. Second port of call, if the amp's not turned on, is to check our remote. Now with the same meter we use to check our power, we can check our remote. It's a low amperage, but typical voltage, typical sort of 12 to 14 volt feed, all right? So we should be able to meter that. Now, if that's the case, if we've got to this point and our amp's still not turned on and we check this, and let's say that we've got no voltage here, all right? We found our problem. That's why the amp isn't turning on, because we've got no remote cable. We need to then either hoy the head unit out of the hole, check why there's no remote cable attachment. I would assume that it's either come unplugged from the radio, or, you know, of course, try and be efficient as possible and check the actual attachment to the amp first, disconnect it, put it back in. I myself have had cases where I've put remotes into amplifiers, turned the whole system on, and then I've chased my ass for ages because I can, you know, I've metered voltage on the remote but nothing's turning on, and it's because I've missed a terminal inside the amp, or I've missed a terminal inside the DSP or something like that, you know. So just re-establish the connection before you go ripping your head unit out, because that might take you a couple of hours, whereas that'll take you, you know, 2 or 3 minutes just with the right tools. So re-establish that, see what it does, right? So we, you know, our amp still doesn't turn on, so we had a good connection to start with, that's fine. We then need to take our head unit out and then check the actual, physically, the cable itself. Now, if the cable's plugged into the radio and the cable's plugged into the amp, but we still have no voltage here, what could be going on? A couple of things could be going on, both as possible as each other, I suppose. The majority, I think I want to say that the actual remote cable might be broken somewhere in the car. Someone might have screwed a seatbelt in, someone might have dropped a seat on it, someone might have stamped on it, depending on how it's installed. The other one might be that the actual remote output from the radio is down, so therefore we'd need to meter it. So we keep it connected and we'd meter it at the car's end, right? So we're getting no voltage here, don't forget. If we meter it and it's connected at the head unit end and we're getting voltage there, then we've pretty much proven that it's the cable. So I would, again, like my mid-range, I would loose lay a remote. So I would just get a 5-6 meter piece of cable, I'd attach it to that remote and go and jam it into the amplifier. You don't even need to connect it, just push it in there and this will fire up, all right? So in this case, we'd have a broken cable. Now, all of these scenarios aren't going to lead to broken cables. It's just that a broken cable is typically the very last thing. So I'm trying to take you through each scenario or each eliminated process, so that you can go, right, my amp's not turning on, I'll check my fuse, I'll check my power at the amp, I'll just give my ground a good old tug, okay, and it's still not turning on, so I'll check my remote cable, I've got no voltage here, right, I've found the issue, I know where it is. We now only need to work on the remote cable. We know the radio's on, so we don't need to check any fusing or any power to that. Like I said earlier, there's certain scenarios where you could just waste a whole load of time looking at stuff when you know that that isn't the issue, or you may not know it isn't the issue, but it really isn't the issue. So a little bit of stepping back from it for a second and thinking, right, okay, if I've got no power on the remote, but I've got power on the radio, that localizes my issue to either the remote cable or the remote output from the radio, okay? So we've governed that, we've metered the remote output from the radio, and we've got 12 volts there, so we know that it's on the cable. So this is broke. Let's fly lead the cable from here to the remote, and bing, our amplifier will turn on. Bit of a pain in the ass. It means you've got a broken cable down the car somewhere, and you've got to run a new remote cable, tie it in and send it down the car, and away you go again. So you've sorted it, all right? Bloody hell. Like I said, none of that's scripted. So this is how I sort out scenarios. I don't care for other pros telling me how they sort out their scenarios. I fix it 100% of the time, every time. So my process is good. Whether you like it or not is a completely different matter. Let's lifetime fix the van, right? So let me tell you about the van. I changed out if you follow the videos on the van, I changed out the Dynaudio 3-way the other day for the 3-way comparison test to the Sony ES 3-way set. Whilst doing that, I know so Stuart changed the crossover point for the mid-range, that's fine, but I kept the laptop connected for my drive home. So the majority of my tuning is done on the road, all right? I don't tune on the road, but I'll keep the computer connected to the system, and I'll find multiple stages where I can either pull over safely and adjust things, because I need to counteract road noise with my tunes. As these are road going systems, we don't sit around in car parks and listen to them. These are, you know, these are to be listened to, and that emotive contact between music, the way that it sounds, and driving a car, it all needs to kind of bond together. So Anyway, I digress. I was driving home with the laptop connected and stopping at certain points so that I can just adjust certain little things, you know, because the Dynaudio and the Sony products, they have different specs. So, you know, the mid-range is different resistance, different sensitivity, things like that. So I'm just adjusting levels and little fine things just for sort of that road going tune. And when I got home, I pulled up on the driveway. I was ready to do my sort of my final little bit, you know, because obviously I was just about to turn the van off and go indoors, and the stereo turned right down, and I've got, you know, the volume hasn't changed. I'm still on about volume 25, but the volume's really low, and I'm thinking, is there something going on here? Where can this be coming from? Now going back to my procedures, my thought process immediately goes to the very top, the very first place where it could be an issue. And I'm thinking, is my phone connected via Bluetooth rather than via Apple CarPlay? I can see CarPlay's on, but is there some sort of software issue? So I check the volume on my phone, because that could lead to that scenario. Check the volume on my phone. It's not that. Of course it's not that, but it needs to be checked. You can't just assume that it's not that. Had a look at that. Had a look at the volume on the radio again, just to, you know, because I couldn't really believe that it was just so quiet. And then I've just had a sort of visual look around. Of course, all the speakers look fine, everything like that. I've looked at the amplifier, and the amplifier on the light on the amplifier. So I'm using the Sony XM8 ES, which is on test as well. Fantastic piece of kit. Well, till we find out what issue this is. The light on the front of the amp was dim. Now, I can't be certain that it's always been bright, but when I looked at it, it seemed different to what it usually would look like. It was usually bright, okay? But it wasn't any different color, it was still white. So it wasn't like it was red or it was giving me any sort of warning. It just gone dim and the output had gone really quiet. So I thought, right, okay, every speaker's working, everything mutes fine, the processor's still connected, software's still connected. I'm thinking, have I had this connected too long? Has the processor wound itself back? Is something an issue here? So I disconnected the processor, turned everything off, turned it back on, and I had no sound at all. Had a look at the processor, all the lights were coming on fine, and I've still got sound on every speaker, so I know now that there's no sort of single speaker issue. I know that there is no necessary output issue from the DSP in terms of its channel separation, but there is definitely an output discrepancy. Where can there be an output discrepancy? From the radio, if the volume's down, right? The volume's not down, it's at 25, so we can write that off. So it starts at the DSP, okay? So we've either got an output issue from the DSP to the amplifier, which is creating a whole system level drop, or we've got an output issue from the amplifier, and the amplifier is trying to protect itself for some reason. Is the amp trying to protect itself from something? Now, I don't think it is. I think that, you know, I know that we have a proven good installation, but what I do have is I have a secondary battery. I have a split relay which runs that battery. The only things that run from that battery at the moment are my amplifier and my DSP. So that's a big one for me. I've checked the relay with my hand, because this all happened at home, so I've got no tools at home. But I'm flicking the ignition, and you know, split charge relays give you a big old clunk when they change over. So I'm turning that. That's fine. That feels, I can feel it. It's getting warm, you know. But what do I do? What do I do about diagnosing it? First thing I need to do is I need to check the voltage. I need to check the voltage at the amp. I need to check, because don't forget, my amp isn't on, all right? So my light went dim, sorry, I missed that. My light went dim, I lost output, it turned right down. When I turned it off and turned it back on, I had no light on the amp. So my amp currently isn't turning on. Few things I haven't checked, because like I say, I was at home, I haven't got a meter at home. I've not checked my remote in voltage, which comes from my DSP, all right? I've not checked my remote input voltage. I've not checked the fuses on the amplifier. I've not checked the battery voltage that amplifier runs from, because if that battery's gone down, or if it's gone dead, or if my alternator isn't charging that battery, then, and it's under, say, 10 volts, 9 volts, it's not going to start up. So let's have a look now. Like I say, this problem exists right now just behind this camera. Let's see if we can figure out what's going on. We'll see if we can fix it, and we can see if we can prove some of these, some of my own diagnosis scenarios. All right, let's go. Right, two things for this. Got my test light, which I can prove ground and power with, and I've got my meter, right? And we're going to be looking at what volts we've got at this battery. We're going to check its fuse either side, and we're going to check its relay. So I'm going to need to turn the ignition on in a minute, but first things first, I just want to check that we have power from the van at one side of the relay, which is this side. So that's that feed there. This is coming from the battery in the van, and then this goes into the relay. The ignition latches the relay. This then allows power to pass through the relay to charge this battery. Then this is my amplifier fuse, and I have a secondary amplifier fuse there, which I'm not too sure you can see on camera. That's just there. Right, so let's get you back in a decent, let's give you some light, hang on. So this tool, I just need to touch the carbon strip, and then I can touch a ground point pretty much anywhere in the car, and it'll give me an indicator of where I've got power. This is good for finding things fast if there is no power. If there's a small amount of power, or say we had 6 volts from the battery, we'll still get a buzz and a light from this, but it'll be quite, you'd have to know the tool to understand, you know, it has quite a bright light and quite a bright sound to it when you've got full voltage, and you just get to know it. But this isn't used to determine what voltage we have, it's just used to determine whether we have voltage, and we can prove ground with it and stuff like that. So I'm going to do a couple of little checks first. I want to check that this battery has voltage for a start, across its poles, so we know that it hasn't had some form of catastrophic failure. We want to test either side of the amplifier's fusing. More importantly, I want to check either side of the relay when it is off and when it's on. I want to make sure it's passing and charging this, because this runs exclusively the DSP and the amplifier. So that's why this is at the top of my hit list. Remember, we've got to go to the top of the problem and kind of work back from there. So let's just check. Like I say, I've got to touch a ground point, and what better than touching the battery's negative pole. So we can see, you can see my light, and you can probably hear that as well. That's got good voltage there. Of course, we're going to have good voltage here, because it's just, we can see that it's connected. There'd have to be some form of issue inside this sort of cable in protection there for that to be an issue. But yeah, let's have a look at the input to the relay. Okay, so we've just found the problem. I've got 0 there, I've got nothing at all there. Let's just prove the tool. Yeah. Right, I've got nothing on the input side of the relay. Okay, so I think we've just found our issue, which means we've got to go even further up the line, because this cable here is what comes from our battery up front, so our starter battery. This is here to protect that battery when we just want to, you know, just have the system on and play it for however long we like. Now, Thursday when I changed these speakers over, I was trying to get hours on these speakers, so I left it playing all day, and it killed the battery for the van. It didn't go down and just shut down, it just wouldn't start when we went to start, so we had to jump start it. I don't know if that could be where that fuse has gone, but either way, we've got to go and now look at the front battery, because I'll guarantee there's either a connection issue, i.e. we haven't connected this this input cable, this one, back up, or our fuse has gone. So let's go and have a look at that now, and we can see how we can test that if it's not visually sort of obvious. This isn't easy with one hand. Great at fixing stereos, no good at opening bonnets. Push it apparently. Right. So I can see we're connected. That's the only power cable we have. Let me just get the light. Right. So You can see that we're connected there. You can see the fuse here. So I'm just going to whip this pollen filter housing off. Pop you on a tripod and let's have a look at this. Funny story. This was off, and I had a horrible buzz coming from inside the heaters one day, and I took this out to find out what it was, and I stuck my hand inside there. I didn't realise there was a massive fan in there spinning at 1,000,000 RPM, and took off the tips of all my fingers.
Oh, no.
Lovely. Come and say hello then. Alright?
Hello.
This is Hunter, everyone, alright? It's Saturday. Right, go on then. Get lost. Right, okay. So, I need a couple of tools for this, because remember, we shouldn't visually prove this. I can see that this is blown. Usually represents itself with a cloudy face on the fuse and then an obvious split in the fuse. But let me just have a little look at that. I'll show you a little closer with the camera, and then get an Allen key and we'll take this off and we'll prove it. We'll prove it before and after. Right, so first things first, let's get a bit of ground in our hand. Now, of course, I can see that bolted to that fitting there. You know, I know that that's going to prove good. But see this on the other side? So we've checked it visually. We can see that it's blown. We don't trust it because it could just be a manky old fuse, but it could work perfectly fine. So we test it. Test one side, test the other side. And if you're really paranoid about it, when you've whipped it out and changed it, you can continuity test it just to prove to yourself that it's gone. But this fuse is gone. That battery's going to start charging. That means my amp turns on, which means my music plays, which makes me happy. So let's take it out. Do not drop your Allen key across your battery terminals. Not a good day. So it's a 60 amp. It's a 60 amp, and we would have underrated that on purpose. We need around 150 amp for this, rated for the relay between the two, and then we can pull from the battery inside, you know, quite heavily. So we'll just leave that there for now. Yeah, because the relay's closed at the moment, this is just a cable kind of going to nowhere. Now I know it may seem obvious, but when we've got this fuse refitted, we should just quickly check across it anyway while we're at it. It's that there like that, that there like that, and I'll give it a little 1/8 of a crank on the long side, just to make sure it doesn't just come loose with any vibration in the engine bay. Take our light, prove that side, and then prove the other side. Right, and now if you come with me, we will go and prove the relay inside, and then we'll turn the van on. Now, we should have obviously power across the terminal, power on the output side, and now we should have power on the input side. Okay, let's turn it on. Ha! I've got my stereo back. Back in the game, back in the game.
We did a warn him, yes we did a warn him, but him never listen, make John draw them yarn.
I love it. One of the favourite parts of my job. Wicked. And turning that on, you'll hear this click. Not the key, listen to the relay. You hear it? Didn't need the meter in the end, did we? Because we thought about it a little bit. Thought about going to the very top of the tree, very top of the diagnostics tree, seeing where it got power, where that power came from, because it's one of the only things that can affect it entirely not switching on other than the remote. And because we had our meter out and our test light, we could determine the remote quite quickly, we could determine the power quite quickly. It's just that we chose to do the power first because it's probably just literally closer to this hole where I could shoot, and we found it straight away. It doesn't often go like that. I hazard a guess that you thought the beginning of this video was a little bit sucky because it was all a bit, oh, you must do this, you must do that. But then when you see it pay off like that live time, then I don't know, it's worthwhile. It's easily one of my favourite parts of the job. I'm going to run you through what I just did, and hopefully it'll be relative to what we discussed earlier on. So if you remember System 2's problem from earlier on, where we lost sound entirely, System 2's problem actually was the remote cable. System 3, we lost it entirely. We had a blown speaker, didn't we? But we did explain in that scenario that it could be the fuse. Now the problem I just had, so earlier on I drew a second battery over here. Now my primary battery feeds my head unit, it doesn't do this. It doesn't go to there, it goes directly to there, or directly to the car. The head unit runs from the car system, right? But there is a link from my battery to there which has a relay. Don't know if that's the terminology for relay, and has a local ground. Alright, I have a fuse in here as well, and I have a fuse in here. I have a fuse here, and I have a fuse here. Everywhere it passes through a piece of metal, we have a fuse either side. So it comes out the seat box, it's fused there. It goes into the amp, the seat box metal is there. This is the bulkhead here. There's no fuse there, there's no need for a fuse there, so this is actually nonsense. But there is a relay there, 150 amp rated relay, and we now have a 150 amp fuse. So what I did when I got into the van, as you saw, the first thing I did was the simplest thing I could do, which is check power. Let's check we've got power everywhere. There's no point in looking for anything else until we know we've proven that we've got power at the amplifier. And we didn't have power at the amplifier because, well, we did, and if we would have checked the amplifier first, it would have thrown us a bit of a red herring. So maybe I should have done that, but just for longevity's sake, but I've got a feeling this video will be long enough as it is. If I'd have checked power at the amp, I probably would have had about 9 volts, which would have thrown my test light off, because that is proving that there's power there or not. It's not proving the voltage. So my next step would have been to use my multimeter to check the voltage, because as I sort of alluded to earlier, I thought it was low voltage. I thought that was the reason we were having snags, and it is, you know. So I proved that we had power at the battery, albeit significantly lower power than we would have with a fully charged battery, because that battery, although it was showing me that there was power there, it was dead. It didn't have enough to run the amplifier itself. So check that we had power there, that's okay. It just means that the inside of the battery isn't broken. Check we had power connected from the split charge relay to the battery, so where it links from the positive on the secondary battery to the split charge relay, just to make sure that that cable hasn't broken down. It's brand new, so I kind of knew it wasn't, but, and then check the input side to the relay. So what happens is you have the car's battery, you have the second battery, then you have a relay. Power, that relay is like this, and then you have an ignition feed, so a 12 volt ignition feed, which comes on when you turn the key. All right, and what it does is it latches this relay shut, and it creates a complete circuit. When the ignition's turned off, it breaks that circuit. All right, so what was happening was turning the ignition on while the relay was open in that circuit. This fuse was blown. So there's actually nothing on this to charge that battery. So the amplifier, which is connected to that battery, has pulled all of that power, and this is now at probably, I don't know, 8 volts, maybe less. So we had no power going into the relay, so we had to go under the bonnet, check the fuse there. And the fuse looked all right. It didn't look mullered, it just looked all right. But as I've said all the way along, you can't trust the way a fuse looks. In fact, you can't trust anything that you assume is going to be okay. You have to check it, check it. So metered one side, which we knew was going to be good, the side connected to the battery, that should always be good. The only way that wouldn't be good is if that battery was completely kaput, or if the cable was cut, or, you know, it pretty much certain that there's going to be voltage on that side of the fuse. And then you check the sort of output side of the fuse, so the flow going from the battery to the other battery, check the other side of the fuse and it was dead. Take it out, have a look at it, kick it across the room because it was useless, put a new fuse in, and bang, we've got everything back. All right, so like I say, kind of glad that that's been relatively simple to diagnose on camera, because I wasn't ready to have a breakdown if I didn't get it to work. But there's no possible way. It was me versus fixing a stereo. It's not a fair fight. So yeah, that's what we did. We replaced this little bugger. That there was creating no sound, which made me unhappy. And now I've replaced that, which gets rid of this guy and makes me happy. Alright? Anyway, that's us sorted. That's the end of that one. Hopefully you've enjoyed that. Hopefully you've learned a couple of things. And yeah, like I say, this is my way of diagnosing issues. I get there quickly, I get it done quickly, I get it done efficiently, and it's all because you just need to sort of remove yourself from the scenario a little bit, have a think about what the last point, the first point in the chain that could be causing you issues, because there's loads of points above it that can't affect that issue. Yeah, so don't waste your time trying to fix it, and certainly don't worry about it. They can all be sorted, you know. Yeah, hopefully you've enjoyed it. Have a nice weekend. I'm Carl. This is Studio Incar. StudioIncar.co.uk is our site. Take a look. Maybe buy some things. I don't know. Have a nice weekend. So this is going to immediately... Oh, good Lord. It's going to